Welcome. My name is Sean Robenheimer. I'm the General Manager of Atvance Intellect. And I'd like to thank you for joining Atvance Intellect in partnership with Splunk and Obscure for our discussion around a very interesting, relevant, and thought-provoking topic of observability. It's an exciting topic, and I've been fortunate enough to be part of many conversations over the past few months with Splunk, Signal Effects, and our customers to help illustrate the value of observability. Today, we have two of the most amazing guest speakers with years of experience and knowledge that are going to help us unpack what observability is and what this means for you in the real world. But before we kick off, I'd like to thank you for investing the time and joining us on the webinar during what has been a few positively challenging months. The agenda is short and sweet and packed with as much value in the time allowed. I'd like to introduce our panelists and speakers. Dave McAllister, evangelist at Splunk with an amazing journey, stories and achievements. His passion for the topic literally brings goosebumps. He's based all the way in the US and joins us at 1 a.m., which shows his passion for sharing his knowledge on observability. Enlin Neveling, CTO of Atvance Intellect, with 20 years plus experience in the industry, an amazing passion for learning, developing and pushing new boundaries in our industry. And Steve Dagg, Splunk focused purely on driving observability with an energy second to none to help customers succeed. A few housekeeping before we kick off. Please ask as many questions as you like in the Q&A section. Panelists will answer all the questions at the end, and the ones that we don't get to, we'll share with you via mail. The webinar is being recorded and will be uploaded to the Atvance Intellect YouTube channel, which will be launching soon, and the presentations will also be shared with you. If you'd like to understand a little bit more after the session, please fill in the survey and your details, and I'll be more than happy to contact you, and we can have further sessions around the topic. Please complete the survey at the end of each speaker, and at the end, this will allow us to obviously add more value in future webinars. And if you complete the survey, you'll stand a chance of winning one of 2,000 Rand takealot.com vouchers. The draw will happen on Friday, and winners will be announced on Monday via email. Once again, thank you for your time and interest. I know that you will enjoy the next 45 to an hour with Enlin and Dave. And without further ado, I'd like to hand over to Enlin Neveling. Thank you.
First of all, thanks for your time and taking time out of your busy diaries and spending some time with us to discuss what a topic that we're quite excited about. And I think in line with the whole observability discussion, it's important to realize that how we did stuff 5 years ago and potentially still doing stuff because of demands our businesses placed on us from an analytics and a monitoring perspective. I think it's important to note that all data pipelines are not equal, and if we're serious about observability and the challenges that it will place on organizations and the demands it will put on staff, it's important to maybe take a step back and rethink the respective architectures we build to support our respective observability requirements. Now, if we take a step back and we look at a 60,000-foot view. Now, anyone in big data has seen and heard of the 3 Vs. What's probably the most important aspect of this is that every organization's challenges with respect to big data is different. We all have different velocity requirements. Most organizations will have different requirements in terms of volume that they need to deal with, and organizations would also have to deal with data coming from a variety of data sources. Some, if they're lucky, they may have one that they have to contend with. Others will have thousands that they need to collect data from. It is important to acknowledge, though, that every single organization's version of the 3 Vs is different. All organizations is at different stages of their respective journeys, and all data has different value to its respective end users. What's important to the one organization may not be as relevant or important to the other. However, and I think before I jump into the next point I would like to make is that how we traditionally did things, our requirements, and if we take a step back around velocity requirements for certain data sets, volume requirements for certain data sets, and variety challenges we may face in that regard, if we jump into observability, they may require a different architectural approach to how we did things in the past. And I think the biggest opportunity most customers have in this regard is to essentially get to a point where they can achieve a level of consolidation, reduce potential total cost of ownership, but still deliver on the promise that observability could bring to modern DevOps environments. Now, if we build this out, data pipelines traditionally consists of 6 tiers. There's a collection tier, a pre-processing tier, pipeline tier, retention analytics, and then a section where we're going to build out our use cases that ultimately delivers the value to the business. Now, these foundational building blocks consist of sources where we would collect data from, which generally speaks to the variety problem in the 3 Vs. This could range from various agents, cloud-based solutions, databases, logs, metrics, traces, APIs, and that list could go on, indefinitely. However, the challenge organizations would face in that space would definitely be, the sheer variety of sources where we would collect data from and their respective formats. There's also a pre-processing phase the data would enter to before it goes into a data pipeline, which is the next phase. And in there, it's called the metadata extraction phase. But in there, you would potentially pause or change the data. You would maybe mask certain sensitive elements within the data. You could extract metadata. There's a couple of things that would happen in the pre-processing phase before it goes into the pipeline. Now, the pipeline is essentially the mechanism that we would use to move data from point A to point B. And that could either be a batch and a stream processing pipeline, which is probably the most it's not the only 2 pipelines, but it's the 2 most common pipelines that you would find in any environment today. Then there's the respective retention mechanisms that we would use. And this could range from relational databases, indexes, data stores. Essentially, your respective technology of choice may have different retention mechanisms and may require different underlying infrastructures to support those requirements. Then we've got the presentation layers, which essentially sits in the analytics tier of the stack. And these is essentially the technologies we would use to present the data back to the end users. Now, this could range from Excel with an ODBC connection to a database, if you will, but in the more advanced environments, you would see anything from Splunk, Power BI, Elastic, Stack, Kibana, really a range of options there. And ultimately, on top of these presentation layers, we would build out the use cases that we would use to deliver the value to the business. And this could range from simple visualizations, alerting, automation, high-res visualization in the case of observability, service mappings, root cause analysis, and debugging in the DevOps world. Now, at each tier, organizations will face different challenges, as we've discussed. Now, first and foremost, in the collection tier, you've got source diversity challenges, instrumentation costs, which all at the end of the day potentially leads to agent fatigue. I sometimes talk to customers and I see the amount of infrastructure and operational technologies they run on a simple device like a laptop or a server, and the amount of resources those respective technologies consume. And at the end of the day, it seems like our systems are working for our respective infrastructures, which is not necessarily the best approach. We also have in the pre-processing and pipeline stages, where organizations would deploy multiple mixed daisy-chained pipelines, and they would hand data off from one to another. And in some cases, these would have been implemented to address shortfalls in the preceding components. Now, and there's nothing wrong with that, and at the time it would have worked for the organization, but at the end of the day, every single component we bring into the pipeline to do something different with the data because the preceding pipeline couldn't, adds to the total cost of ownership. It adds to the skills we need in the environment, and it adds to the overall problem, which is complexity and total cost of ownership of this monolith solution that we end up building. TCO in terms of retention is always a major challenge. I think everyone complains about disk and infrastructure related costs in this regard. And almost all organizations sometimes treat every data requirement as a new requirement, and they tend to approach it in a tactical way. And this kind of, led me to think, maybe there's a way we could do this differently. Maybe we could look at our whole approach to data analytics in a more strategic way by simplifying some of the components. We'll talk a bit about that a little bit later on. And then, because of the complexity and the disparity and the wide range of solutions that we're using underneath this, most organizations struggle to extract value from their data, irrespective of the mechanisms and tools they have at their disposal. And every single organization, because of the complexity and the different methods they use to collect data and visualize them, struggles with probably the most valuable capability they could achieve, and that's correlation. Now, if you typically look at pipelines that we've seen in organizations today, you would see that this is kind of what these architectures end up looking like. And there's absolutely nothing wrong with it. But I think what you hear in all of these situations is that everyone complains about complexity, everyone complains about total cost of ownership, and everyone complains that, maybe our approach to analytics is not necessarily delivering the value that was initially promised. And because of this, I think it's important that we understand the underlying technologies that we use to move data from point A to point B, to enrich data, etc. And therefore, I want to jump into the next slide and just spend some time on the differences between the two major pipelines we're using in our respective environments today. And that's the first being batch processing pipelines. And these would typically be your traditional Hadoops, your Elastics, Splunk, your traditional SIEM solutions in the security world. They all use some form of batch processing pipeline. Secondly, if we unpack the pros and cons of those, you would find that these are excellent for large volumes of data, historical analysis, and detailed insights. The cons, though, and keyword here, relatively, they're relatively slow in comparison to streaming. Now, you'll have a discussion with someone that's running traditional batch processing pipelines, and they say, but we're moving data from point A to point B in anything between 1 and 5 seconds. Now, that sounds fast, but if we get into microservices architectures and we looking at the complexity and the rate of change within those architectures, 1 and 5 seconds is actually not fast enough. And we'll unpack that a bit more, and Dave is going to spend some time on that as well. However, one thing I need to make very clear is that these are still very relevant for large number of use cases, and various use cases will support this type of pipeline for years to come. Next up, streaming pipelines. And these words have become quite common and synonymous in most IT infrastructures. Kafka, RabbitMQ, Flink, Storm, SignalFX, which a big portion of the discussion is about today, Graphite, Samza, etc. There's really a range of solutions out there that you can choose from. The pros in this regard is really the fact that we can achieve sub-second latency in terms with high fidelity data. And we can achieve high frequency alerting, which is extremely important in the DevOps and observability world. The cons there, more focused on real-time streaming, and events tend to be a bit smaller than what you would typically see in the batch processing world. Now, these are driven by high fidelity data streaming requirements and high frequency real-time alerting requirements like DevOps and observability. Now, if we had to visualize this and typically how these two pipelines differ, just from an alerting perspective, you would see that it would look like this. Data would flow at the top through a batch processing pipeline and would go through different queues. That process in itself takes time, and the way that search typically works on these pipelines kind of works in a batch, in a scheduled mode. So you will not be able to achieve the high frequency alerting. And in some cases, some of the pipelines would also aggregate the data when it comes to metrics and traces specifically. I'm not referring to traditional log collection and that you would collect from a Windows event log. We specifically are focused on metrics and traces, which is very relevant to the DevOps and observability discussion. As you can see, the pipeline at the bottom, which is essentially a representation of a stream processing pipeline, is extremely fast when it comes to alerting, and the fact that we can do high fidelity searches in very quick space of time. Now, how does this translate to advance in the solutions we want to take to market? I think what's important there, if we have to go back to those foundational building blocks, it's important that we're pretty much a Splunk shop, right? We live and die by Splunk, and a lot of people thought that initially, you know, this may be a risky move, but I believe, and I think the team believes that, you know, with the amount of resources we've got, we can really add value to the product and add that value and extend that value to our customers. And Splunk obviously went down a road where they are obviously expanding their platform to address the same challenges that we've identified. And it made sense for us to align with them because we can really provide an end-to-end solution at a much lower total cost of ownership, we believe, than what most of the other complex solutions would bring to the mix. Now, first and foremost, at the collection tier, the Splunk Universal Forwarder is probably one of the best collection agents for traditional logging and other metrics that out there. And we would use that to collect data from pretty much anything in combination with other components within the architecture. Then we've got SignalFX, the SignalFX Smart Agent, and that in conjunction with open source technologies and open source capabilities, like the Cloud Native Foundation projects, Jaeger and Prometheus. You also have open telemetry. And what's key here is that SignalFX is probably one of the biggest contributors in that space. And this is so relevant because if you read the latest Gartner APM, the APM Magic Quadrant, you would note that Gartner says that by 2023, don't quote me on the numbers, I may be a year out on either side, about 53, and again, don't quote me on the numbers, 53% of customers would rely on open source technologies like Jaeger, Prometheus, Open Census, Open Tracing, and CollectD to do the tooling and the instrumentation within their respective application architectures. Now, this is quite relevant because no customer wants to retool and re-instrument their respective technologies every single time they switch monitoring or analytics vendors. So there needs to be something that's kind of an accepted standard within the industry that needs to do the collection. And technologies like SignalFX can literally plug in on top of that and perform something called auto-instrumentation, which makes it very easy and very seamless to ensure we get the metrics and traces off those systems. So those two kind of go hand in hand. In the pre-processing phase, we obviously have various mechanisms across the different technologies. We've got Splunk apps, which you've probably seen in Splunk base, that will do various pre-processing functions before the data goes into the pipeline. SignalFX does some really cool stuff with data as it moves through their respective pipelines. And then there's open source capabilities we would use from time to time as well. To address our traditional batch requirements, Splunk Core is probably the flagship product in the market today. You know, Gartner constantly recognizes them as a leader in this space, and a lot of our core capability in our business was founded on you know, pretty much what Splunk Core can deliver. Splunk then obviously last year went on a bit of an acquisition spree, and that's where SignalFX comes from, but they also did a lot of internal innovation, and they delivered a product called Splunk Data Stream Processor, which is essentially a streaming pipeline, but the application of this would be more in a very complex application architecture where different components need to share data in a very fast, real-time manner with each other to make sure that these can effectively communicate with each other. And Splunk DSP is key for that. There's also use cases in anomaly detection and fraud detection where something like Splunk DSP can add a significant amount of value in. The second component there, or third component essentially in the mix, is SignalFX, which essentially is our solution we bring to market if customers are serious about collecting metrics and traces to support a observability strategy. Splunk has also done a great job, and they'll continue to do a great job to ensure that these components are integrated, which addresses the correlation problem that most customers struggle with. Now, Splunk has shown over the last couple of months that they are definitely dedicated to making sure that these components come together in a single pane of glass. So this is the core components that we would typically collect data with. But in terms of use cases, Splunk has also invested quite heavily in purposefully built solutions that is essentially a combination of use cases and capabilities that they've bundled into products that we as a systems integrator can take to market. Now, this ranges from Splunk ES and Splunk UBA, which is predominantly security products in the traditional security world. Splunk ITSI for IT ops and ITO and DevOps requirements is essentially a single pane of glass and set of use cases that you would overlay on top of your IT data. Splunk MLTK, which is Splunk's machine learning app. It's a free app for anyone that's got Splunk core, and it essentially extends a whole bunch of open source machine learning algorithms and allows you to use that on top of the data you've got on your platform. Splunk Business Flow is a capability that essentially allows us to visualize data throughout a business process and identify key bottlenecks within that business process in the business analytics world. And then we've got Phantom, which is a automation and orchestration product that essentially allows us to automate a lot of the workloads associated with security and IT incidents. SignalFX obviously is key to that whole conversation of making sure we can get a lot of the IT incidents into analytics platform as fast as possible. And SignalFX comes pre-shipped with a lot of integrations for very complex monitoring environments like Kubernetes, a lot of the cloud providers, and that's really where they shine. And VictorOps is essentially the technology we would use for on-call situations where we've got our big teams on standby, and we would escalate calls to the different teams with VictorOps. And essentially all of these solutions, SignalFX, Splunk, they all form part of the same platform driven by the same company, which we've then complemented with tactical and strategic services. And hopefully what we're able to do at the end of the day with all of this is to deliver a much more simplified approach to data pipelines, where we can essentially build a solution that's fit for purpose, irrespective where your 3Vs would take you as an organization. This gives us capability to provide customers with very fast communications between applications in Splunk DSP from very complex and very fast data sources. We've got Splunk Core, essentially connecting different sources in the organization, traditional logging and event collection, all the way up into Splunk Core, ITSI, ES, and UBA with MLTK on top of that. And then we've got SignalFX, which essentially brings a lot of value to the metrics and trace world, and obviously delivers that to ensure that we address a lot of the challenges we will face around observability. With that, short and sweet, I'm going to hand over to Dave. So thank you for your time. It's truly appreciated. I would like to take a moment just to introduce Dave, as our guest speaker. Dave is currently providing technical evangelism for Splunk. Dave works with DevOps developers and architects to really understand the advantages of modern microservices architectures. Dave's also been a champion for open systems and open source from the early days of Linux. Dave also frequently speaks publicly. I think if you want to do a vanity search on Dave in Google, and you'll actually see what a profound impact he's made in the market today. So, and also he's passionate about IoT and messaging standards and how scale in those environments, impacts IoT decisions. So I think I couldn't be more pleased to hand over this to Dave and to close out on the session. So Dave, thank you for your time. I'm going to hand over to you, and then, the show's yours. Thank you very much.
Thank you, Enlin. I really do appreciate that. And thanks for taking the time and spending with me today. Let me get my screen up and shared for this. So I'm going to cover, come on, there we go. I'm going to cover something a little bit more different about this. And I want to talk about how observability impacts today's world, especially when you're looking at modern applications. That introduction was spot on, but everything Splunk does is around data. Whoops, there we go. And we also like to consider that every person is a million points of data here. So thought I'd share 3 points with you here. First of all, I am married, so I have a witness that I don't read minds. If you have questions, please drop them into the Q&A, to the chat, so that we can cover them later on here. I spent 10 years as a soccer rep, so I'm used to people disagreeing with me. In fact, I'm used to 50% of the people in the field disagreeing with me on any given moment here. And I'm owned by 3 cats, so I'm actually well trained at being ignored. Like many of you, the recent difficulties around have changed things. So as of today, the Bay Area, where I live in California, is in its 115th day of shelter in place. So I am on my home network, and we'll deal with that as it comes out. So why are we even talking about this thing around observability? Well, the world has changed a lot. We've gone from the concept of applications being a very single environment. Here's your server, here's your application. The application is tightly coupled, one set of code inside of here, everything written in the same environment. And things are very slow. So it wasn't unusual to see new releases come out on an 18-month cycle. We're beginning to see people move into the first step, which is moving to a public or private cloud environment for this, what's called a lift and shift. Take the same functionality and put it into an infrastructure that's based on a cloud environment. And then we move into the refactoring, where people start breaking apart and making use of separate, more modular services, but still dependent. And we see containers start creeping into here. And we see container orchestration, Kubernetes start creeping into here. And then finally, we get to the true cloud native architectures where things are microservices based and things are serverless based. In fact, one of the previous mentions was that with batch processing, you could see a significant length of time, even though 1 to 5 seconds doesn't sound like a length of time here. It can be. In a serverless environment, a serverless startup cycle in AWS is about 400 milliseconds inside of here. And the average execution for an AWS Lambda server, serverless environment is about less than 1 second. So if you're waiting 5 seconds for your results to come in here, you can have missed a tremendous amount of activity that's happening if you're in a serverless environment. So what about this observability? Well, this is where I like to start. My favorite quote from Arthur Conan Doyle, of course, Sherlock Holmes here, you see, but you do not observe. Because unless we're beginning to look at all of the different pieces that make up our application environments, our infrastructure environments here, we're going to start missing things that live underneath the surface for that. And that surface itself leads us to the concept that says, what is observability? So observability is a quality of our software, our systems, and platforms that lets us understand how they're behaving. In the old days, we used to use the concept of black box and white box in monitoring environments here. And black box basically said you'd ping the box and say, are you alive? And the box would come back and say, yeah, I'm fine. Go away. Don't bother me. Now we have to start looking at what the activities are going, how things look inside of the picture across the board here. Because the issue is around the amount of data. So from an engineering viewpoint, and observability as a concept that's been around for quite some time here, is defining the exposure of state variables so that we can determine the behavior of the service. Think of this in terms of driving a car. If your dashboard light comes on here, it's going to tell you that something's wrong. But we need to have more information now on what is wrong inside of that. And therefore, we make those variables exposed to allow us to determine what is actually happening inside of that environment here. So observability is a signal to noise problem. Actually, it's just a signals problem. It is actually a big data problem. And when we get into a little bit, we're going to talk about this monitoring pattern called RED, which provides this filtering approach. When you have a lot of signal here, you actually have two basic ways that you can approach this. One of them is a filtering mechanism. Cut down the amount of data so that the only data that you're getting is the data that you deem to be here. And it can be done by sampling, pull 1 out of every 100 pieces of data here. It can be done by more intelligent sampling, or it can be done by another approach, which is to take it and apply capabilities at the back end to allow us to make sense of the signals themselves while also retaining the ability to drill in. And this is where RED starts creeping into this. Microservices applications, very honestly, can have hundreds of applications. The FAA SWIM, Software-Wide Information Management System, can be hundreds of different microservices driving at any given moment across this. So observability isn't monitoring. This is one of the myths that you'll hear quite often, but observability requires monitoring. Observability is our data, our telemetry sources coming in here. It is an attribute of the system. It is almost, from a viewpoint, monitoring is the verb. It's the activity that we take on that data here. And there can be lots of sources of data here. You'll hear about the traditional ones, the 3 pillars of observability, which come into this: metrics, traces, and logs. And they each have a role to play inside of this environment. Metrics: do have a problem? This is my traditional monitoring and alerting functionality. What is going on? Has something appeared inside of here? Troubleshooting, the tracing distributed. Where is the problem? This lets us start taking apart the activity that's happening inside the system and pinpointing the area of functionality. And then finally, logs. What's causing this problem to appear here? Metrics are compact, they're efficient, but they're probably not enough to allow you really truly debug or determine the cause of a problem in here. Logs and events are full fidelity, but they're very bulky at capture, and they are dependent on the person who has decided what information to report at a logging functionality. Traces, or distributed tracing, is actually pretty cool stuff here, but it can require work, either instrumentation directly into an application or auto instrumentation functionality, such as what SignalFX does here, to be able to capture and establish those traces, pieces of data. So let's take a look at a quick example of what a microservices architecture looks like. And this is a fairly traditional example out of Martin Fowler's book on microservices here. This is the Amazon CO UK site. And each of these pieces are something you can see on a screen here. But each of these pieces is broken down as its own unique service. And behind that service are other services inside of here. So for instance, looking up what the inventory is goes to a database functionality. Looking at the price service can look into what the pricing structure is, can look into the need to convert currencies around here, all the way down into people who are looking at what other people bought and suggestions for you inside of this space are all other pieces, and they're all driven by services. So this front page, or this page for a book, is actually going to be about 55 microservices by the time you actually go through the entire environment. So microservices are an architecture as well as a model for making things continuously available. It's a distributed system. It is in many ways the grown-up version of what we knew as SOA, but with a fully distributed development model with the full capabilities to be resilient as well. So there is a couple of things that happens. We talk about observability, but observability really should be a loop. And if you think about this, observability is the ability for us to have the data that's coming out of the process and application inside of here. And it goes through and it's delivered through something called telemetry. One of the references earlier was to an open source project called OpenTelemetry. Splunk had doubled down on OpenTelemetry. It is our ingest process for this observability data going on. And we are members of CNCF, the Cloud Native Compute Foundation. And over the last quarter, we have more than double the number of contributions that have gone into the OpenTelemetry effort. We are committed to making open data access a major portion of this space going forward here. So telemetry is our logs, our traces, our metrics. It can actually be anything we want it to be for this. I have one customer base who brings in their Twitter feeds, analyzes their Twitter feeds because they know their customers will always tell them something's going wrong before anything else catches it. We move into that. That considers the observability, the monitoring aspects in here. However, observability has this control thing, controllability, and that allows us to be able to respond back to and control what's happening inside of this application. That could be manual. It could be an instant response, an alert being triggered, somebody's pager going off inside of here to tell them that something needs to be looked at. Or it can be automated, run books, or just an automated response. So if you deploy a new product, you see that there's a problem with it, the system can roll it back out. So loops can be open or closed inside of here, but observability really is a loop, and you need products that complete this loop for you. If all you can do is see it and not control it, it actually isn't very useful for you in doing that. So what is RED? Well, RED is what's called a monitoring pattern for here, and it's a subset of what was the Google's golden signals, or the SRE related work that came here. It was originally mentioned by Weaveworks with a hat tip to a gentleman named Tom Wilkie inside of here. It's made up of these concepts of rate, error, and duration. And it's really designed for request-driven systems or microservices where we have requests going through a system. Inside of this, you'll see various pieces inside of here. In the example here, you can see the request, you can see error rates, and you can see durations, a P50 and a P90 in this particular case. It's important here to note that this data should not be filtered before we get into the red bases, because then our durations are no longer accurate. And let's see here. Sorry, my screen is not working with me. So why does red even matter inside of here? Well, inside of our new world environments, when we're dealing with public clouds, when we're dealing with hybrid clouds or multiple cloud bases, we find that the complexity matters. We have lots of moving pieces and lots of interrelations here. We're now sending data, we're streaming data between microservices. And when we start adding in things such as container orchestration or serverless, we have lots of things that aren't there anymore. And so we need to be able to take this complexity, bring it into a simplicity and abstraction so we get rid of the clutter. We get rid of that surrounding noise, and we can understand what's being shown to us in a way that we can quickly grasp and grab it. However, we need to retain that complexity so that we can figure out what the headache pieces are, what's going on, and how we can control it and make it changes for the difference here. So red is basically monitoring at what I call a Chuck Norris level. And it comes down to the concept of monitoring has traditionally been the see something and maybe say something. When we get into observability, we need monitoring that is see something, do something inside of here. And our rate and our errors and duration can really break down into the three categories of metrics, logs, and traces here. It allows us to recognize the issues that are happening, the alerts and the problems that are going on here, as well as recognize what the root causes of those problems are. This becomes incredibly important when we're dealing with customer bases and we're dealing with very fast, what I call instant gratification society. There's a Google study that points out that if a person waits 3.7 seconds for a web page, they are likely to leave your site right then and there. And it's even worse when they're bringing out something like a shopping cart. They tend to abandon the shopping cart. At 5 seconds, they'll go complain to their friends about how slow you are. So we have not only the problem aspect, but we also have the performance aspects that come into play in the observability space. So rate, pretty much any number of the requests on the network, and it can be handled through any mechanism. It can be HTTP request, REST request, it can be through that middleware messaging and queuing, functionality could be API calls, it can be overhead like service message and the control messages of Envoy or Istio or Linkerd in here. Any environment that can fail on peak traffic is a target for rate monitoring. You need to keep an eye on what's going on with that rate functionality. And the rate functionality will give you that standard information, the request, what the request points look like, and give you more and more information. Again, simplifying this very complex structure in such a way that we can quickly grasp it. Errors, incorrect, incomplete, or unexpected results here. Errors can show up in production. They can show up in communication headaches here, but errors require rapid responses. Again, think back to the fact that a serverless environment is done in less than a second. We can't wait 5 seconds to see that a problem occurred here. The difference is that errors require you to deep dive and have high fidelity. This is where every piece of data is really important. And when you have errors, you need them right now. As soon as you possibly can get it, you need to be able to dig in and figure out what the headaches are going on there. Errors, pretty much the same thing. You'll have an error rate. You can see what's happening to it, and you can look at it from endpoints for this. Duration, it's time. It brings things into order here. And it answers the questions like, what was the event? How long did it take? Why did it take so long? And which service is responsible for the time side that appears inside of that? And again, we can see that we can see an average functionality, 10 seconds going across here, how it's distributing, and what its endpoints look like. So why do we even think about this red environment here? Well, red is easy to remember. I'm pretty sure that most of y'all can come out of this talk and go, red is rate, error, durations inside of here. However, it has other advantages. What we've seen is that companies, especially in microservices organizations where microservices are managed and built by separate groups scattered through a company, there's a lot of discussion going on around what they need to track and how they need to track it. And red is a starting point for reducing the decision fatigue. So start with red. You have a basis of structure that goes across here. You also have a standard way of approaching it, so everybody understands what an error means and what a duration means into here. So you have a consistency and a common language that crosses all these pieces. The nice thing is that red is infinitely tailorable. So each group can actually expand their red structures to provide the specific sets of information they want here. And red, because it is providing that standardization and language, allows us to get into automation and provide that automation functionality. And finally, interesting enough, red can serve as this proxy for something we call user happiness. We know that users really do want to see things go through as quickly as possible. And red can tell us across the commonplace what's going on inside of our systems, so we can see whether things are working for our users or not. And when we get into high fidelity tracing, we can actually go all the way down to a single user and see what the cause of happiness or unhappiness for a specific user looks like. So it's important to keep in mind that while we're talking about these three things, they can cross the streams. So each of those pieces can also have different structures and different functionalities. Slow rates could be caused by errors or caused by a communication problem that's going on inside of here. Errors could be caused by a failure in communication, a slowness in duration, or an overwhelming amount of rate inside of here. And duration can be caused by, again, an error that's happening or by a bandwidth limitation. And so each of these pieces can impact what the others are showing you inside of here. So you need all three. So keep in mind that having only one piece doesn't give you the entire picture. It gives you part of the picture. The three together give you the ability to truly understand what's happening inside of your application space and your infrastructure space. The two work together as well. So in summary, and because I want to step into and show you a little bit about sort of a demo of what red can mean in here. So observability is more than monitoring, but monitoring is an important part of observability. It expands it to white box monitorings, where we start understanding what's happening inside of those services. And red wins from microservices-based applications. However, red is useful in any request-driven functionality, where you're tracking a request through its various components to see what the start points were to what the concluding points were here. Red also takes that complexity that we're seeing here and simplifies it so that we can understand it, use automation techniques, and be able to have a common language when we're talking about these different things. It also, though, allows us the ability to step into it, get inside of it, and understand the insights that are important inside of here. And then, keep in mind that red can interact in interesting ways, and that what you may be seeing is not necessarily the pieces that are as important for each of those pieces for here. Let me do a couple of really quick little things for this. This is fairly important. When you start looking at observability, there are actually two viewpoints that are happening here. One is the external customer's viewpoint. It's singular. They only care about the request at this moment as latency, how long it took, and whether it was successful. An operator's viewpoint is looking at the overall, all of the latencies, the rates, and the concurrency inside of here. And we need to be able to drive both of those pieces inside of here. And then my philosophy, I ran a nonprofit for Stanford University called the Philosophy Talk for a while. And so I get to talk about that. But instrumentation by itself is not an answer. It'll help you find an answer. These tools are only as good as the data they give you and the ability to allow you to actually find the answers inside of here. You're observing the work. You're not necessarily observing the service, but you're going to observe the service anywhere. And you want to see how the service is responding to the workload. As your workload goes up, does your service expand? Does your service handle it? And while we talk about observability, observability is not your goal. You don't necessarily want to deliver observability, but you're still trying to do reducing the MTs, if you will, the mean times to detection, response, and resolution. So let me do a real quick and step into. This is actually a live demo that is running. This is an e-commerce environment, and you're looking at a red chart for a specific service. In this case, I'm looking at an API service for this. During this, you can see a couple of things here. You can see the request rate. I'm running at 22 requests seconds down to 10 over a 10-second period. So I am aggregating my information coming in. My request latency is running at 270, 280 milliseconds. It's pretty good for a request rate. And I've got a 15% error rate that's happening inside of that. There are some other pieces that are showing up here. I can look at it in detail going across, but I can also take a look at what's going on with the underlying system. The host metrics are actually pretty important inside of here as well. Applications run on infrastructure, and therefore the two of them work together. I can go all the way down. In this case, this is a Kubernetes environment based on containers, and I can actually start looking at what the Kubernetes metrics are across this. From here, I can start looking at this. I really don't like the concept that I'm looking at a 16% error rate, sorry. My cursor has decided to disappear on me. This is kind of weird. Let's go back for this. So what I'm going to do is step into this, go up, there we go. There's the cursor for this. And so I'm looking at this. And what I did was I went to the dashboard. What I can see very quickly is now that I've got a red for all of my services for here, rate, error, duration. I can see what's happening across all of the services, and I can start seeing how they interact. So again, I'm going to step in here. I have a problem. Let's step in here and look at what's going on. In this problem, you can see that size makes a difference. That I can see what the average transfer rate between the endpoints were. And by mousing over any of these, I can get its specific red environments here. If you notice down here, I don't show a root cause at this point in time. All of my little things are hatched mark for here. So now I can go in and start using artificial intelligence functionality and see where the errors are rated. In this case, I can see that I've got errors that 2,000 plus errors are coming from a payment service. So now I can do the service. So I'll add the checkout service, which is the next in line here, and I'll add the payment service to it. And now I can show all those different things inside of here. From here, I can start making use of additional functionality. I can start doing what's called breakdowns. And this gets me into the ability to start drilling in farther and farther to the environments here. So for instance, I'll take a look and say, this is my tenant basis that's happening inside of here. Gold, platinum, silver. Gold and platinum are having problems. If you remember, I've got little red lines going on. Silver seems to be just fine. You can see how my requests are tracking through each system to these pieces. Over here, let's grab this, and I'm going to say, well, let's see, is it version? I've had a new version relate. Nope, they're both blocked. It's not version. Let's try and see if there's an underlying structure problem. And here I now asked for the Kubernetes nodes, and I can see that 2 of my nodes are working just fine, and 1 of my nodes has failed, or for some reason like that. I can then step into it and start looking at even more detail. And what I'm going to do is load up the tracing data. And the tracing data shows me specifically what's happening inside of any particular request. So for instance, this request has failed, and I can see all of the information around its failure. I can also see that I have a 402 code, which is a request timeout. So I have something that's happening that's keeping my system from operating correctly. I can pretty much guarantee that this platinum person is not pretty happy about this because the request did not go through. It failed pretty quickly, but it didn't go through. I can also see the breakdown of things where the applications are, where it's in the database, and where it's in the networking at any particular time. And so that gives me the ability to start taking a look at this. Every one of these things has the ability to expand and see what its functionality is. I can also show all of the trace information at any time because I keep every single trace. I can not only show the ones that are problematic, but I can also show the good ones so that I can always do a comparison back to the environment. But let's go back. I'm gonna grab this, make sure that I've got the payment up here. I'm gonna step over to errors of request. And if you remember, I had a Kubernetes node problem. So now I simply wanna step in here and let's take a quick look and take a look at the Kubernetes node. So now I've stepped from my application space into my infrastructure space to start looking at what's going on. Generally speaking, in this environment, you would be going off to a terminal window and doing a kubectl request to be able to pull this information, the node properties that are there. But I can quickly find out, for instance, down here, nothing suspicious about the names or anything, that I have one of my containers on this node is running at 91% of its memory. And so I'm not quite sure what's going on there, but I can also step in and look at its container properties the same way and find that my memory limit is set to unlimited. This is probably a configuration error. It's pretty easy to fix, but it may not be enough. So I've got payment services running inside of this as well. And for instance, I may want to simply step into the Splunk environment and take this for a bit, sign in, and actually take a look at what the log data is now telling me. And now I can see that I have an out of memory error, that the Java heap request is going on, that this is thrown an exception inside of here. And I can find out specifically what is happening at any given moment with my data. So now I brought all 3 of those pillars of data together. I've got metrics that are showing me that I have a problem. I have traces showing me where the problem exists. I can go from the application space into the infrastructure space, and I can go all the way down to the logs that are telling me what actually happened at that moment in time. This is what observability is all about, the ability to bring all of these pieces together in such a way that we can understand and grasp the quick visualization all the way down to finding and resolving the problems that we need. So with that, I'll turn it back over and we'll have time for some questions. Do we have any questions, folks?
Dave, thank you. Can you hear me? Apologies.
Yes, yes, I can.
Fantastic. Thank you very much for that. Just quickly we have a couple of questions. Can everyone see my screen?
No.
All right, let me just share it. Give me 2 seconds.
There we go. Got it.
Okay, can you see the Q&A screen?
I'm seeing the lower part of the screen. I'm seeing the breakdown.
Right, let's get that right. Sorry, apologies. I've had a bit of a challenge with my now.
There we go.
Oh, fantastic. Dave, Enlin, thank you for the thought-provoking insight into observability and how we can apply this in the real world. I think it's going to help businesses address real problems in the future. I know it's not easy to take the years of experience and compact it into an hour, but you truly have given us some really good insight into the power and the value of observability. My next mission is to get you in front of our customers here in South Africa, and I hope that in the coming months that we could potentially put together a bit of a roadshow. I think you would add a huge amount of value and thought leadership in this space. And that's definitely something that we'll look at doing in the future. So there's a couple of questions that have come through that, if you don't mind, I'd like to just get to. If you give me 2 seconds, apologies, I'm just finding the questions. So Dave, this one goes out to you. So how do I get started with Red?
So, that's actually a great question. And most people believe that Red is going to require that they rewrite their applications. And quite often you'll hear people say, oh no, you have to instrument inside of this. Actually, that's not the case. You can have auto instrumentation techniques. If you're using Java, for instance, just drop an agent into place. It will auto instrument and keep track of it for you. There are library approaches that simply allow you to put it in place with your code lines and bring it in. Or if you're using almost any of the more modern service meshes, they're all pre-built for you. So it's very easy to get started with Red. And for instance, people that are using things like the Prometheus functionality or even collect D functionalities already have the capabilities of bringing Red into play here. I've actually seen a Red implementation that was driven purely off of logging data. Now, not necessarily easy, but you already have your logs running as well. So it's easy to get started with Red. Very simple. We at SignalFX, we have a whole series of tools and libraries, but Open Tracing and Open Telemetry both have those libraries as well that bring that data into place.
Fantastic. And I think probably one of the biggest questions that we've got over the last couple of months, talking to our customers around observability and microservices, is monitoring, right? A lot of customers have already invested in monitoring capabilities. And the question we get is, why doesn't my current monitoring cut it?
That's actually, I love this question. I actually have a companion talk, which is how monitoring and observability work together, but we don't have 90 additional minutes to cover this here. So monitoring tends to be the ability to see what's going on a large scale view. So it tends to start with an infrastructure environment. What are my servers doing? What's my database doing? What's my network doing? Somewhat to the application is working or the application isn't working. Observability gets us into a totally different level, which is how is the application working for my specific user at a specific moment? And it starts getting us the ability to answer what are commonly called unknown unknowns. So monitoring is quite often about what we know to look for. We keep a track of this. This is why we call it monitoring. We already looking for it to be there. But now something has gone wrong. Observability is the ability to answer those questions. And that's where the two fit together. You have to have monitoring. Your monitoring is going to get more fine grained. You may be monitoring different things that you've not thought of before. But observability allows us to drill into that data and actually find out things that are going on post-fact. And so the two work together. You're still going to keep your monitoring, but observability is going to give you this, oh my God, something went wrong and I didn't know what it went wrong, and figure out how to fix it so it doesn't happen the next time.
Fantastic. And then the last question, also something that I've actually been wanting to ask for some time now, is that can Red be used in places that aren't based on microservices?
Absolutely. So the concept of Red is really started with this discussion around microservices, but it's actually for anything that is what's called request driven, where there is a starting point and an ending point, or hopefully an ending point that's not an error for this. So if you are simply building an e-commerce system, whether it's a microservices based environment or a more traditional web front end going to some sort of back end, Red works in that environment. It requires that the ability that we can recognize an individual request and that we can follow that request through its journey through the system. And that's where things started. Microservices as an architecture has been around for a while, but we still have a huge amount of applications that are built on a purely request-driven model, and Red still works just as well for those.
Fantastic. I appreciate that, Dave. Thank you. So those are the questions we have. There'll be additional questions that we'll add that we'll share with you both on the YouTube channel and with you via email. I just want to take this opportunity, Dave, to thank you very much once again. I know that it's late early there where you are. Your knowledge and experience, and I know it's not easy putting all those years of experience into such a short space of time, but we really do thank you for that. Just in closing, I'd just like to thank everyone for joining us. Please go and check out our YouTube channel. Atvance Intellect will be launching the YouTube channel shortly. This will be the first webinar that we will be uploading to it. Remember, we'll also be sharing the PDFs and the presentations with you. If there's anything or any additional information that you would like to see, if you'd like to come and understand a little bit more of how we can help you in context of your environment, please reach out to us. Don't forget to complete the surveys. These surveys will put you into a draw to win 2 vouchers, gift vouchers, and you need to complete those surveys. The draw will be taking place on Friday, and we will announce the winners on Monday. In that, I'd like to close off. Thank you very much. I wish you guys a wonderful afternoon and a fantastic weekend. Thank you.